There we are. We're
Yay,
back.
that worked. Yay!
Dun, 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 dun.
Copyright.
All right.
Yeah.
Well, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Edutainment, the Sunday Night Astronomy Show. Yay! Okay.
There you go.
I'm so happy to be here.
We got a whole roll.
All right. Enough of that. My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I'm also an amateur astronomer. We were discussing that just a few minutes ago. Amateur astronomer.
Yes, that's
And a
right.
member of the Royal Astronomical Society of Canada. I'm very pleased to welcome back my two regular co-hosts this evening, Mr. Paul Owen from the Moonshadow Observatory in beautiful Hampton. Paul, good evening.
Hello, good evening.
And my other co-host this evening, Mr. Mike Powell from the PFO Observatory here in St. John. Mike.
Good eve.
Hey. Good evening.
What do we do? Manam, manam, beep, 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 beep. Manam.
Anyway, we'd like to welcome all of you tonight and all of you who are joining us for the local Rogers TV network. Thank you so much for your support, everybody from Facebook and YouTube as well. On tonight's episode of the Sunday Night Astronomy Show, well, spring is galaxy season. And we're going to talk. Oh, hang on, now I get my other notes. So that's our show for this evening.
Thank you, good day, everyone.
Yeah.
Hope you enjoyed it.
Oh, wait, we'll just talk about it. Anyway, spring is galaxy season, and we're going to be talking about galaxies tonight. We got a couple of favorite galaxies that we want to mention. We want to know about your favorite galaxies too. If you have one out there that you enjoy the most, maybe that was the one behind me here. That's the one I kind of like the most, I guess. But everybody has their favorites, and that's what we'll be talking about tonight. Galaxy season really goes from about March till about mid-May or so. And that's the time when the galaxies that we want to look at, or the majority of them that we want to look at, are up the highest in the sky in around 10 p.m. or so. So we're looking at now in the sky in the southeast or south, I guess, around in the south part of the sky around 10 p.m. now. We have Leo up really nice and high, and we have Virgo right behind it. And in that space between Leo and Virgo is the spot we call the realm of the galaxies. And if you zoom in there, you'll just see hundreds and hundreds and hundreds of more galaxies. And you don't need a very big telescope to pick up. Even a 6-inch scope will pick up these little dust balls. And they'll be the galaxies themselves. And it's very easy to get 2 or 3 in your eyepiece at once if you're looking at, if you get a wide enough field of view in that area that we call the realm of the galaxies. So we're going to talk a little bit about galaxies tonight, what they're all about, and show some of our favorites. We'd like to know what your favorites are too as well. And if you've had a chance to take a look at any of them or capture them even as well. So I guess I was voted to start tonight. So I'll get my presentation brought up here. Just bear with me for a second. I'm going to try to share my screen. I got to bring it up first.
Still bearing.
Okay. And I'm going to go to screen 4. Okay. All right. Well, we good there?
Yeah.
Yep.
Okay. So what are galaxies? Well, galaxies consist of stars, planets, and vast clouds of gas and dust, all bound together by gravity. Now, the largest contain trillions of stars and can be more than 1 million light years across. The smallest can contain just a few thousand stars and span just a few hundred light years. The most large galaxies have a supermassive black hole at their center, with some billions of times the sun's mass. Galaxies come in a variety of shapes, mostly spirals and ellipticals, as well as those that are less orderly appearances, usually dubbed irregular galaxies. So most galaxies are between 10 billion and 13.6 billion years old. Some are almost as old as the universe itself, which formed about 13.8 billion years ago. Now, astronomers think the youngest known galaxy formed approximately 500 million years ago. Our own galaxy, the Milky Way, is a spiral galaxy with a disk of stars spanning more than 100,000 light years. Earth is located along one of the galaxy's spiral arms, about halfway from the center. Our solar system takes about 240 million years to orbit the Milky Way just once. The Milky Way sits in a neighborhood with over 50 other galaxies called the local group. Its members range in size from dwarf galaxies, smaller galaxies with up to a few billion stars, up to Andromeda, our nearest large galactic neighbor. And tonight I want to talk a little bit about not one galaxy, but a bunch called Markarian's chain. And this is in that patch between Leo and in Virgo. So it's a chain of island universes, I think is how they refer to it. So Markarian's chain is a string of galaxies located towards the center of the Virgo galaxy cluster, a group of some 2,000 galaxies. Now, when viewed from Earth, the galaxies lie along a smoothly curved line. This chain of galaxies is best viewed in spring when the constellation of Virgo is at its highest. And this photo is by Paul here. Thanks for letting me borrow that, Paul.
Yep, no problem.
And they got a couple more here. The right members of the chain are visible through small telescopes. Larger telescopes can be used to view the fainter galaxies. Near the center, there appears to be a pair of interacting galaxies, NGC 4438 and NGC 4435, these two, about 50 million light years away, known as Markarian's eyes. They're pretty cool. That's from Jason Dane. And Markarian's chain was named after Benjamin E. Markarian, an Armenian astrophysicist who was the first to discover that galaxies share a common motion through space. At least 7 Markarian galaxies appear to move coherently, while others are merely superposed in the same line of sight. That's pretty cool. This one's from Tim Doucette. He zoomed in on the Markarian eyes there.
Yeah, right on.
Cool.
Wow.
Very nice.
Okay, so I mean, galaxies are huge and billions and billions of stars, up to 1 trillion stars. And where can we find this one? Well, we can find this chain right in this area here. So here's Leo, the lion up here, and here's Virgo. We're looking at southeast right now about 10 p.m. Atlantic time. So we can look and find Leo with this bright star Regulus down here. So this is easy to find. You'll actually see the shape here. It looks like a backwards question mark. And follow that right down, and you'll actually see that shape pretty easily in the sky. Down below that is Virgo, and right off the shoulder of Virgo right there is where we find the Markarian's chain. And zoomed in a little bit more, sits right in this area right here. But you can see these other galaxies that are all around the same area here. There's a Leo triplet, another famous group of galaxies. And over this way to the east is when we start seeing the globulars start to pop up, the globular clusters, which are our summertime targets. But right now it's galaxy time. Okay, a little bit about galaxies. Let's take a look at the scale of the universe as represented by stars and galaxies. So all the stars we see at night in the Milky Way are in the Milky Way with us. We reside about 25,000 light years from the center on the Orion spur. 1 light year is 6 trillion miles or 10 trillion kilometers. And we share this space with over 300 billion other stars and probably billions of planets, or tens of billions of planets. Now, our Milky Way, though, is just part of a larger cluster known as the Local Group, a collection of 3 spiral galaxies, our Milky Way, Andromeda, and the Triangulum Galaxy, and dozens of other dwarf galaxies, with probably a number of them not discovered yet. Now, the number of stars in the Local Group, over 2 trillion. We go a step farther. Our Local Group is part of the large cluster known as the Virgo cluster. Now, it's a collection of 2,000 galaxies and spans about 15 million light years. And the Virgo cluster is just a small section of a much larger group that we call the Virgo supercluster. Our supercluster contains over 50,000 galaxies and spans over 100 million light years. Now, the number of stars in the Virgo supercluster, over 200 trillion. And final step out, we're going to take one more step out to look at our neighboring superclusters. We're now looking at all galaxies within 1 billion light years of home. Our Virgo supercluster is just a minor member at this scale. Galaxies and clusters of galaxies are not uniformly distributed in the universe. There are actually large areas void of any galaxies. Can you imagine being in this Booty's void here and not knowing where you are, just black all the time? There are actually large areas void of any galaxies. At this scale, we are looking at over 60 million galaxies. Now, the number of stars at this scale, over 250 quadrillion. One final note, there are millions of these superclusters in the observable universe. We have just seen less than 7% of the complete picture.
Wow.
Wow. Like you said.
That's a big place we call the universe, isn't it?
Yeah.
We were talking earlier, and Mike made an interesting point that if you were to fly, say, to Andromeda, maybe not Andromeda, maybe another galaxy,
Another galaxy.
other galaxies, you'd never get there.
Right.
And go ahead, Mike, and tell them why.
Well, it was just an article I was reading online the other night, and I thought the same thing. What are they talking about? Well, if you left Earth at the speed of light, headed for another galaxy, the galaxy is expanding faster than the speed of light, so you would never reach the galaxy you were headed for. It would be expanding away from you faster than you are getting towards it. I thought, wow, that's crazy. In fact, you would see it getting further and further away from you the whole time, even though you're headed towards it at the speed of light. It's
But we're still supposed to collide with it in
well, Andromeda, but I say another galaxy, say the Pinwheel.
yeah.
Like you wanted to head for the Pinwheel galaxy. I think it's further away than Andromeda. Then technically you would never reach it because it's the universe is expanding faster than you can go at the speed of light. It's actually expanding faster than the speed of light, so you would never reach it.
So how fast can we travel now?
I don't know.
Not
2/3 the speed of light, maybe. I don't know.
But anyway, that's an interesting question because
We can't travel anywhere near that.
yeah,
I mean, the Voyager spacecrafts are only traveling at what, 17 kilometers per second.
Oh yeah, I mean,
to the left, and then I think the Parker Solar Probe is the fastest one, and I don't know the exact number. I'd have to look it up on how fast the Parker Solar Probe goes. But I mean, you're talking about 300,000 kilometers per second. Well, we're not there. We're a long way away from there. Just a tiny fraction.
Then again, Einstein said nothing is impossible. It just hasn't been done yet. There you go.
Yeah. But anyway, I just thought that was a really interesting fact.
Another interesting fact as well that I was come across is, and I've heard it before, but it really clued in this time. The reason we can see, all these galaxies towards Leo and Virgo is because you're looking perpendicular from our galaxy. So if it's a flat plane, you're looking this way, and there's not all the stars and dust in the way. You can look the other way, same thing, but you can't look to the sides because you hit the Milky Way galaxy and you got to see through all those stars and all that dust and everything else. But where you're perpendicular and looking straight up away from that plane, then it opens the sky right up and there's billions of galaxies in your view.
Yeah.
Kind of cool.
I think we have to realize that there's so much that we're not even seeing. We're only seeing a very small portion of the visible there. Parker Solar Probe is at 692,000 kilometers per hour. How many kilometers per second that is? I don't know. I'd have to divide that out, but that's from Mike. So I think that's the fastest probe or spacecraft, you want to call it, that we have right now, is because it's making loops around the sun, right? And it's being pulled in. It's actually flying. They say it's touching the sun. Well, it's in the chromosphere, but it's not actually touching it or but I think that's the fastest one right now. And even at that, 692,000 kilometers per hour, and you're 2.3 million light years away. So you're going to be a little,
It's going to be, you want to pack a lunch.
Yeah.
Kind of like the Voyager probe, right? 2.6 million miles away, or it only has 206 million miles on it, but the radio still works.
Yeah, it does. It's slow, but it's there.
I mean, who was it? Somebody said something about the most cool image they ever saw was when one of our space vehicles was heading out, and when it looked back and it saw the Earth as just a small blue dot.
Yeah, Carl Sagan, pale blue dot.
Yeah, pale blue dot. Yeah.
Yeah, how insignificant.
Yeah.
And we're not, but when you're out there, it is.
Yeah.
I sometimes think if you're having a rough day, you're thinking, oh man, this is my life, is this, or whatever the case. And then you start to think, okay, you know what? If you were out there and you were looking around and how far away you could be from whatever's ailing you at the moment, and how fast time goes, because again, we're talking about billions and billions and light years, and here we have a little dash that goes, for on the average 84 years.
Yeah.
Yeah. Yeah, your lifespan is nothing compared to the universe. I mean, it's just, it doesn't care. I mean, you're insignificant, but you're also significant because we may be the only species that has ever looked back at where we came from.
Yeah.
We don't know that, right? So, or
Yeah.
had the opportunity or had the knowledge to be able to, to be conscious, to be able to say, or sentient, I guess, to
But
say.
a long time ago in a galaxy far, far away.
Now, that's a different story. Mike
But I
Thorne
guess
says,
it's all about scale, isn't it?
oh, it is. Yeah.
Because depending on where you sit in a scale of things, it can be significant or it cannot be.
Yeah. Astronomy provides you with humility, I think.
Yeah.
It makes you very humble when you're sitting underneath the sky. You don't have to be there with optical aids even, you can just be sitting under the sky watching a meteor shower and realize how tiny or how significant we really are, but how insignificant we are to the universe, right?
Yeah, yeah, to the grand scheme of things.
Just go on Google and type in Carl Sagan pale blue dot, and that video says it all.
Yeah.
Yeah. Yeah.
It says it all.
Yeah. I saw
humbling.
once a video Chris did or showed, and it showed basically going from leaving Earth and then going out and to seeing the vastness, but then coming back into Earth, then going into a human and going down to the microbiome and everything, right?
The two universes, really, yeah.
Yeah.
The two universes, the macro and the micro, right?
Yeah, the macro and the micro. So everything, depending on what scale that you are in, has significance, but yet if you're not in that scale, then it may not. Like, I don't think about a little molecule inside of me. It's not.
Ever since Men in Black, I'm afraid to open lockers in a bus depot.
My head shrunk once. Anyway, I just thought that was kind of cool.
So, Mike Thorne says the Parker Solar Probe is traveling at 191 kilometers per second, which is 0.064 the speed of light.
Wow.
It's the fastest object ever built. Yeah.
0.064.
Oh, and that's insignificant, isn't it?
Yeah, that's pretty tiny. We got to go a long way. And then how do you protect your spacecraft if you're going to be out there? Because, I mean, a speck of dust.
Yeah.
That you're traveling by all of a sudden becomes a missile, and now you need shields around you and, warp field. And
yeah. So I wonder how fast was warp 10? Wasn't there a warp 10 from Star Trek?
Warp 10 meant that you were in every place at the same time, supposed to be.
Oh, okay.
So that's from a Star Trek Voyager episode. Anyway, good luck. Not that I watch that kind of stuff.
Yeah.
Episode, yeah.
Yeah, if he turns off his background, he turns off his background, he's got all the videos up on the.
Oh yeah.
VCR tapes, yes.
Geez.
Okay, Mike, do you want to go?
Let's go with Mike now.
Sure. Let me share here. Share. I think it's going to be this one. Share this screen and see what I get. So, my favorite galaxy.
Hey,
of course.
Is M101. Kind of looks like a hay bale on its side, right?
Pretty big.
So Messier 101, or the Pinwheel Galaxy, also known as NGC 5457, is a face-on spiral galaxy located 21 million light years from Earth in the constellation Ursa Major. It was actually discovered by Pierre, I think you pronounce that, Michain, in 1781, and was communicated that year to Charles Messier, who actually verified its position for its inclusion into the Messier catalog as one of his final entries. So all those galaxies out there, that was one of the last ones he added to his catalog. Where would I find it in the sky? Well, everybody knows the look of the Big Dipper. You can't miss it. I look and say these first two stars at the end of the handle. Of course, we know this is Mizar and Alcor. And the first star here, if you drew an equilateral triangle up off of those, guess what? You're going to nail M101 dead on. You can't miss it. And it's actually pretty bright. Looking at it in 10 by 50 binoculars, I know this is a small picture, but I mean, you can actually physically see it in dark skies with 10 by 50s. It's there. An 80 millimeter refractor with a 50 millimeter eyepiece. There's your view. Not bad at all. And of course, if you start using the Smith Cassegrains and you drop down to a 9 millimeter eyepiece, you start seeing some detail with it. Now it's still, going to be that fudgy spot until you start taking photos of it. But yeah, it's an amazing sight to see. It's easy to find, and right now it's placed perfect in the sky at night at around 10:30, 11 o'clock. And then I love this shot. This is Hubble's high definition shot of
Oh,
it. Now I'm going to pull up this picture here because then I can zoom it. You see that one? Is that zoom?
that's
Yeah,
wow.
that's it, yeah.
So, I mean, we were showing Paul and Chris earlier. Look at this. You're looking through this galaxy to all these other galaxies in here behind it. Another one over here. You come down, there's another one over here. Like, and these are behind it. 3 or 4 more over here. I mean, just incredible the detail that Hubble got in this shot. This is a 500 megabit image that you can download from NASA and the Hubble site of the Pinwheel Galaxy. So that's pretty cool. I mean, I can't even imagine the amount of stars that are in that galaxy alone.
Yeah.
That's one of my favorites, the Pinwheel M101. So
Isn't it the blue areas? And like, bring that back up, Mike. Is it blue areas that are the starburst areas, or is it the red areas? One is
Well, that's the star clusters. Like there's so many clusters.
Hmm.
Yeah, if you zoom in, like all of those arms, when you extend out to them, the extended parts, that's where you start to see all those clusters form.
because the stars are all moving at a different speed, right? I mean, relative to the center of the galaxy.
yeah,
And some areas the stars would bunch up, like because some are moving faster than others, right? So yeah, that up in the top left there, Mike. Right up in that area, or even right,
in here,
yeah, in there maybe.
and down in here. All of these arms, like you say, but like I said, it's just and of course this is the Hubble palette. I don't know what the colors are, but
Well, that's an RGB image. That's the RGB that we would
see. Yeah,
yeah. There's no false color there.
that's pretty cool, man. Look at even the dust lanes alone, just amazing.
That's just unbelievable. And to see
that
on your computer. Oh wow.
So much detail in that shot. You can just keep going and going and going, and it doesn't get blurry.
Yeah. That's amazing.
Okay. Thanks, Mike.
Yeah.
Favorite? Paul, you got a favorite?
Yeah, I do. I'm not going to get into as much scientific detail about the one I chose. I'm going to get more into why I chose it and what it means to me, because it was at the very beginning of my journey in astronomy, really. And actually, Mike had a part in that. And when I first got my first real telescope that I could see more than the moon and the planets with, the first thing I wanted to find was Andromeda, because that's the one that everybody heard. Well, the Andromeda, find that. It's so easy. You know what? It took me hours to find because I just had a manual telescope. I didn't have the go-to electronics, nothing like that. So I went on the hunt. And I got to tell you, I think I got more excitement and enjoyment out of finding that galaxy when I finally found it than I think that if I had have just punched it into a computer and let my scope go see it, because I would have been more, oh yeah, that's kind of a funny looking smudge. To me, it was after when I first, because I was still new to astronomy, so everything was new and all that kind of stuff. So when I first found it in the eyepiece, I freaked out. I was out on my deck in the back, and I was looking through a little 150, 650 Newtonian telescope on the mount. I still have the mount here with me, and that was back. Oh my God, that would be 10 or 11 years ago now, because I haven't been in astronomy as long as you guys have. Anyway, when I found it, I come running in the house, and I was freaking out. I said, "You won't believe what I saw and what I found." Blah, blah, blah. And now, because I know where it is and I had to find it that way, I can go out in my backyard now and just look up at any night and say, you know what, I can naked eye see, look right there. I can point right at it, don't need anything. And it was all because I took the time to kind of try to find it. But it was the excitement of that galaxy that got me involved into imaging and all that kind of stuff. So that's kind of my story about why I chose Andromeda. I'll show you just a couple of pictures here. Let me just find out where I put that file first. It's probably right underneath them, no doubt. Just give me a second here. Where are you hiding, by? Just give me a second. I know it's here. Hide that one. Move that one. Oh, there it is. Got it. Got it. Okay. All right. So I'm just going to share a picture, or a couple of pictures actually. So I'm going to find out where I can open that up first. And I'm going to show my very first picture of Andromeda when I first got into imaging. And I was so proud of this. All right, let me just share my screen. And here we go. There it is.
There you go.
Sure.
I think that's better than my first image.
Better than my last image.
That's what I call the green blob.
Yeah.
And look, you know what? I posted that online, because I was so excited that, oh my gosh, this was after I finally figured out how to throw a camera into a telescope, and this was just with a DSLR, and just the way you start. But the excitement that I had just getting that first image was just like, I can't believe it. And then now, as I improved, my next image of it was like this one. I mean, look at the awful colors and stuff, right? But didn't matter. There's, the 3 galaxies that are associated with Andromeda. And I thought, wow, man. And I was still at that point of hype, of excitement about astronomy. And then I got into, I got relatively okay at imaging. And then I was able to come up with this one. And that's kind of where, you can get into looking at all kinds of stuff on this image like you couldn't before. But to be totally frank, I never got the same experience from this at this level that I did when I first found that Andromeda in that telescope. I can't trump that. I just can't. And so what I do now is when I do imaging, I don't really necessarily do it to try to create a pretty picture and then try to compete with people, because there's just so many people that are doing such great astrophotography now. And to be totally frank, most people are shooting the same targets anyway. And anybody who's getting at certain levels are doing certain techniques. So a lot of it is kind of the same old, same old. Every once in a while, an image will pop out that's just amazing. And then, of course, you'll clap to that person and congratulate them on it. But what I do with them now is it's the same thing Mike did with his galaxies. I'll actually go into it and I'll start digging around and I'll start looking for those star nurseries. So this image here was shot with RGB, the same as that Hubble one was, but I also used hydrogen alpha so I could find all those chunks of star nurseries, which are all those red spots. So you start looking around Andromeda galaxy in the outer arms where it actually starts to spiral out, and there's just all kinds of those nuggets all over the place. There's the blue cluster areas of newly formed stars, but these are the nurseries, these pink hydrogen alpha regions. So it's the neat thing about deep sky astrophotography is if you really want to study this stuff a little deeper, just for your own enjoyment, or looks things up when you find something and then go on the internet and reference it, you can really become quite educated just on galaxies and what's in them and how they're formed. And when you're looking at one, it's not just that gray smear anymore. It's like these things have significance, and they can tell us a lot about who we are and all that kind of stuff. So I find that is really, really, really interesting. So having done that with the Andromeda galaxy, for those who want to know how to find it, I think I made a reference to it here. Hang on. Yeah, right there. So Andromeda galaxy is in the constellation Andromeda. So it's pretty easy to find. All you got to do is find Cassiopeia. Everybody knows that one. And Perseus, Cepheus. And it's kind of right in here. So this one here with all these lines that you see is the Andromeda constellation. Here's the galaxy itself. So if you can find Cassiopeia, and there's that W shape of Cassiopeia, or M, depending on where it's sitting in the sky. The most elongated star angle that points out like a triangle, that one points right to Andromeda. So if you see that longest part, just kind of look over at a slight arc by about, I don't know, a few degrees, and you'll see what looks like a star, but it's kind of smudgy. You can see that with the naked eye, and you're actually looking at naked eye Andromeda. So you can find that with the naked eye, but that's where you find it in the night sky. Andromeda is one of the most photographed galaxies that are out there because it's a large, large, large target and it's really quite bright. So, so it makes it an easy target for us to find. Now, in the meantime, while I was doing some of these other galaxies and stuff, some people have heard of, I think it's this one. This is, I believe, M106. So when you're looking at galaxies like this that are far away and you're trying to take pictures of them, and you're not using, great big giant Schmidt-Cassegrain telescopes, getting you, filling your screen with just the galaxy, you can see a lot of that stuff around it. And Mike loves wide field. And the reason you like wide field is because there's a lot going on around certain targets. So look at the galaxies. So here's 106, but look at all the galaxies that are around it that are just so cool to look at. And I had no idea when I went to images, because again, I'm not a studying astronomer in a book and about galaxies. I'll find them and then I'll find out what's around them through my images. And then, so here's, look at, there's just like a gazillion galaxies in every angle that you go away from this one. So when you have an image like that and you start getting inside, then you can start to see the galaxy structures. Are they Sidon? Are they elliptical? Are they, shaped like our spiral in any way? Anyway, it's just really, really cool to see that. It's M106. There's one other galaxy that you guys ever hear, the Deerlick group?
Yep.
Yeah.
Okay, so the Deerlick group is like this. It's one galaxy, but it's got a whole bunch of F beside it. So one night I was talking about that, and I said, okay, I'm going to show you a picture of the Deerlick group. That's my Deerlick group. Anyway, that's my little spin on Andromeda and what Andromeda means to me, and how Andromeda really got me truly excited about looking up at the night sky and just knowing that there are so many treasures that are up there, that if you take the time and just, it's between you and the sky, and it's not Celestron and it's not Skywatcher, it's nobody else, just you and the sky, and look through an eyepiece and just find things. And I got to tell you, man, it's, if I could get that same buzz again, that newness and that excitement, I haven't found it yet.
Yeah. Yeah, it's discovering something new in the eyepiece, or discovering something new that you haven't seen before in the sky. Like when you're
Right.
looking up, I'm still stuck on when I'm looking around the constellations. I can pick out a few, but I don't know a lot of them.
Yeah.
Then when I'm looking for treasures inside them, and if I look, like you say, for Andromeda, I'm looking at the Great Square of Pegasus. And then I usually just go 2 stars out, 2 stars up, and boom, it's right there. And the
Yeah.
same thing. And that's like star hopping, right? It's a method that you use to find things on a manual scale, so that later on you can find it again, kind of thing.
I think a lot of it is that you've achieved something. When you set out to do something, and in the beginning it was so hard because like when I was doing that, I had no idea about charts and that kind of stuff. I just went out and said, I'm going to find this galaxy, and I went hunting. And it's just being able to do that without just pushing a button and have it done for you.
Yeah.
You know what I mean? So there's something to be said for that.
I had the same feeling when I was looking at M13 for the first time. I was like, Andromeda didn't really, in your case, it was because you had found it and you were amazed that you're looking at another galaxy. For me, it was the same thing with M13. I was looking at, a 500,000 stars, and all I could picture in my head was, what would my sky look like if I was in the middle of that cluster? Where, could I survive, for one thing, with the radiation kill me? But if I was to look up at the sky, and there is a couple of astronomers that calculated out what the sky would look like, so many stars would be brighter than Venus and blah blah blah. But it's just like a little island on its own, like a big ball, and that was the first thing that really fascinated me like that. But galaxies themselves, there's so many different types, and there's so many out there. You can't get bored, especially at this time of year when you're looking at galaxies.
Yeah, that's it.
That space between Leo and Virgo is a very rich area, right?
Do you remember that Land and Sea episode when they came to Fundy and they did the
Oh, yeah.
recording for the star parties and stuff?
Mhm.
And then at the other end of it, they did a whole thing on Tim Doucette.
Hmm.
Tim's parting words were something along the lines of, "How can you not be amazed?" He says, "Because we're all from, we're all from Stardust."
Yeah.
Yeah.
And
Yeah.
how he said that, and I know he still feels that way today about it.
Yeah.
And but yeah, it's that connection. But you have to have that. I don't think an electronic thing for that kind of a feeling. You know what I mean? I don't
Yeah.
know. Maybe I'm wrong.
I did, for me, it's been a long time since I've been out underneath the sky, and I long for it right now. Like when
Yeah.
I go weeks at a time, it's like I'm grumpy because I haven't been out underneath the sky just for an evening. It's getting back to it that always, and it's that connection that you look for, I think.
Yeah. Yeah.
Life gets stressful enough, but it doesn't matter how bad your life is. Tomorrow morning the sun's going to rise in the east, and or somewhere in the east, southeast maybe, or whatever, but it's going to set in the west. So get over yourself. You're not that important.
Oh yeah, but it's peaceful, isn't it?
Yeah.
Like when we do those star parties, and then after all the public have gone back to their tents and whatnot, and we sit there usually just the three of us by the end of the night, and there's nothing like sitting in a lawn chair, just laying back, no scopes, just talking and watching fireballs.
Yeah. Yeah.
You know what I mean? Just
And
sitting and looking.
satellites.
Wow, did you see that? And
Yeah. Yeah. Just looking around the sky.
Anyway,
We're pretty lucky to be in this part of the world to have that ability too. Like, dark skies are a natural resource for us, really,
Yeah.
as much as forestry or fishing or anything else is. It's a very pleasing spot on the planet to be, and our light pollution is getting worse and worse. So we're still very lucky to be where we are. I think
yeah, in this part of the
5,
country.
10, or 15 minutes outside of any city, really, and be in the country where a spot like you have, Paul.
Yeah.
All right. Let's go on then maybe to albino bud. How's that?
I know, bud. Yes.
I know, boo.
So get out there and enjoy galaxy season, folks. Even with binoculars, you don't need telescope.
Nope. Binoculars, just like Bino Bud uses.
Just like bino bud would use. There you go.
Well, alrighty. Binocular target of the week this week by Bino Bud is, are you ready for this one? Snazman, turn left at Mini Cassiopeia.
Where's my hat?
I didn't have you facing that way without one or with a hat. You have to send me one. I'll get it fixed up.
Oh,
The question is it W or is it M? Well, who knows? So this object is an asterism located in the constellation, and Kurt talked about this last week, in Draco. Little Cassiopeia, or Kembel 2, sometimes called Mini W. Due to its size and relatively faint stars, this asterism is really a better binocular target than naked eye, but you can actually see it naked eye. It's pretty big. Well, how would I find it in the sky? Well, tonight, if you went out at midnight, oriented yourself 25 degrees north-northeast and looked up, you'll see Hercules constellation. You'll see the Little Dipper. Come right in between the two, and you got Draco. If you come down to this star, and it's one of the brighter stars in Draco, and look right in this area, you're going to find Mini Cassiopeia. Here's a little closer view of that second star. You come down, look, there it is right there, a little W. And if it's that big in this picture, you'll see it in binoculars. What does it look like? Well, looks like a version of Cassiopeia, only smaller. That's why they call it the Mini Cassiopeia. And 10 by 50 binoculars, and there's three. It looks like an M in this picture, but you can make out that it's a W upside down, and real easy to find and real easy to see. And you go, wow, that is a mini version of Cassiopeia. Compared to the full moon, it's actually, from one side to the other, about the width of a full moon. So, hey, if you can see the moon with a pair of binoculars, you'll go up and you'll find Mini Cassiopeia, and you'll be able to see it with a pair of binoculars as well. And are we ready? What do you call an astronaut or an astronomer's favorite dance? The moonwalk. Hey, you don't get it. Oh. And that's Binocular Target of the Week by Bino Bud. I like the moonwalk.
Okay. Oh, Paul, you're muted. We couldn't hear you laughing, Paul. I think that's what Mike was waiting for.
Oh, okay. I
Oh,
was,
I saw his face break open. So
and I asked, I said that that guy had both gloves.
he did.
You had to.
Oh.
Just back to the comments here. Derek King said, I did the same thing as you, Paul, when I was looking at the Andromeda, I guess. Andromeda was my first galaxy and was all manual to find it. And I was no different. I ran into the house, got everyone out decide to see it. The little
Oh,
smudge stays.
fantastic.
There you go.
I ran in, told the wife, and she went, "Yeah." Don't bug me. I'm watching my show.
That's nice, Mike. That's
Yeah,
nice.
that's nice. Get out of here.
Go on out and play.
Yeah. All right, let's go to Rosanna's fun fact.
All right.
Week. What you got
Oh,
on us
that's
fun
funny.
fact this week?
The moonwalk. All right. Okay, hang on now. Let me get one part of my puzzle correct here. Where'd it go? There it is. I think I've got it. All
I'm
right.
gonna say,
This
I'm gonna
is,
say happy birthday to Peter before we start because Peter started this
oh,
up for us. Yeah, today's I believe is his birthday.
who's Peter?
Peter Visma, who did the
Oh, Peter
Rosanna's.
Visma. Hi, Peter. Happy birthday. Wow.
Yeah.
Another day older and deeper in debt.
All right, let's go. Here we go. This is this.
Peter's the voice we hear coming up here. Yeah.
Rosanna's Fun Fact.
Hey, welcome back, Rosanna. This fun fact is actually a really, well, like they all are, but this one's really kind of fun, especially for those who like to walk and hike. And so this is a great story, and I enjoy this one. So let's get going with it. So Rosanna writes, "Hi, Paul. As the days warm up, the hiking group I belong to is starting to plan more frequent and longer hikes. Although we are not mountain climbers, we do encounter some steep climbs. Season-wise, March to May, we are in the middle of what is considered the best time to climb Mount Everest. But what does that have to do with space?" All right, well, let's find out. Hang on here. Did I get the wrong one up? I did, didn't I? Hang on. There it is. Make sure I got the little arrow. There we go. Okay. So take a look at this photo. So this is the European Space Agency shared this image of Mars to celebrate the 25,000th orbit of the Mars Express spacecraft. You can see there are three of Mars' famously colossal volcanoes in a row. From left to right is Arzea, Pavinus, and Ascraeus Mons. And with the mound of Mars' largest volcano, Olympus Mons, at the top of the frame. So that's this one way up here. So the humongous volcano, Olympus Mons, is a result of a dynamic and tumultuous geological process that have shaped Mars over billions of years. Olympus Mons is approximately 72,000 feet or 22,000 meters tall. It rises 13.6 miles or 22.9 kilometers above the Martian surface. Its summit is marked by a caldera, a large depression formed by volcanic activity spanning 50 miles or 80 kilometers wide. The mountain slopes are gentle, but its sheer size is so vast that if you were to stand on its base, the summit would extend beyond the horizon. So as you can see, the Olympus Mons is nearly 3 times the height of Mount Everest, but with such a wide base. And there's Mount Everest right here, this mountainous area in the bottom. Because this has such a wide base, all of its slopes average only about 5 degrees. At such a mild grade, climbing Olympus Mons would be an extremely long but relatively gentle hike. This led me to wonder if anyone else had thought about space hiking the highest mountain in the solar system. Well, of course. A research group in Sweden did a study on what it would take to climb Olympus Mons, and they found it would take a total of 645 days, including flight time, and an insane $38 billion. That seems like an outrageous cost for a hike, but there are some things to consider above and beyond just getting there. To climb Olympus Mons, first, you'd need oxygen. Over 95% of the Martian atmosphere is carbon dioxide, with only trace amounts of oxygen. Therefore, the air is unbreathable. You would need to require, you would be required to carry your own oxygen supply, and that would slow down the pace of the trek. The Martian atmosphere is exceedingly thin, about 100 times less dense than Earth's. The scarcity of air means that you would face extreme cold, with temperatures at the summit potentially dropping to minus 112 degrees Fahrenheit or minus 80 degrees Celsius. At the summit of Mount Everest in peak climbing season is about minus 30, but it can drop to minus 60 or even minus 70 with the wind chill. Now, the lack of air on Mars also contributes to the massive dust storms that envelope the entire planet. Once dust particles lifted by the relatively mild winds, they can stay suspended for weeks at a time and be carried over vast distances. Navigation and maintaining equipment functionality in these conditions would be challenging. Your $1,400 ramp site compass from Aircraft Spruce Canada probably wouldn't work. So Mars offers little protection against cosmic and solar radiation due to its thin atmosphere and lack of magnetic field. Climbers would be directly exposed to radiation, so protective gear beyond the thermal and oxygen supply systems would be a necessity. As far as the actual terrain, Olympus Mons has a relatively gentle slope compared to the mountains on Earth. Its large size and gentle gradients mean that, technically, the physical act of climbing it may not be as demanding as the steep ascents of Earth's highest peaks. The challenge lies in vertical climbing and more in covering, the challenge lies less in vertical climbing and more in covering the tremendous horizontal distances involved. To reach the summit, one would have to hike nearly 200 miles and gain at least 72,180 feet of elevation in the process. But hang on, Mars has a gravitational pull that is just 38% that of the Earth. The reduced gravity on the red planet would fundamentally alter the hiking experience, providing advantages. So, you would find that your steps lighter and you would find it easier to carry the weight of the oxygen tanks. So the strain on muscles and joints would be markedly reduced, allowing for longer distances to be covered with less physical fatigue. Piece of cake, right? On the flip side, the reduced gravity could affect your sense of balance and coordination. Humans evolved under the Earth's stronger gravitational forces, and it might be a struggle to adapt. Furthermore, the lower gravity could have long-term health implications such as muscle atrophy and bone density loss, issues already observed in astronauts after extended periods in microgravity environments. I could not find the breakdown for the actual days out of 645 needed just for the hike on Olympus Mons, but it would take 270 days just to get to Mars. It didn't say if the total included the return trip. Considering what's involved, the $38 billion price tag no longer seems that outrageous. So, although summiting Olympus Mons in the distant future, I'm sure it will happen, just not in my lifetime. Meanwhile, Mount Everest is definitely closer, and the cost averages between $30,000 and $160,000. That might just be why it's becoming so popular. And you see all that long lineup? Oh no, that's just a line for the ladies' washroom. And that is this week's something.
Rosetta's Fun Fact.
Hey. Now, wasn't that cool?
It'd be quite a hike, wouldn't it?
It'd be quite a hike indeed.
I'd take a chairlift to the top and slide down.
More like it.
Well, it's almost 2 years
Wow.
to get,
Wow.
but it wouldn't be such a hard hike, right? Because the gravitational issues and the pitch that you'd be climbing it.
Mhm.
Anyway, I just thought that was really, really cool.
It's cool.
So thank you, Rosanna. Another
Yeah.
wonderful fun
I think
fact.
I'd probably go for Everest right now, but yeah, that one would be pretty cool. Okay. Yeah. How she finds these stories that just, or how she
I
thinks.
know. I'm so glad she does.
Awesome. Okay, we're gonna go to some photos now before we sign off. I'll just open up here in give me a second. I'm gonna up the right screen. See if it come up properly. No, they're doing the same thing again. Why are they doing that? Let's do it this way. Open with just photos. All right. Share my screen. Or some photos to share. Nice.
There we are.
Here, okay. Full screen. There we go. Okay. So this one comes from Kathy Adams. Kathy captured Bode's Galaxy. She's Bode's Galaxy, approximately 3 hours integration time. Tried the new C-Star script that Cyril, Siril, just developed, and stacked and pre-processed in Cyril. Finished up with Photoshop. Turned out pretty good.
There you go.
Wow, nice, eh?
Not bad at all.
Very nice.
M81, M82 are the two galaxies that you can get in the eyepiece at the same time if you get the right scope, right? And they do look pretty in there. Here's another one she got, Sombrero. This is my favorite. Well, this is probably my favorite. Yeah, Sombrero. I love Sombrero. 2 nights of data on the Sombrero Galaxy, about 2 hours of integration time, says, stacked in DSS and processed in Photoshop.
Yes, sir. That's a heck of a dust lane there.
Isn't it? Yeah,
Yeah, that's cool.
yeah. Love that one. And third one, the Sunflower Galaxy. 2 nights of data for the Sunflower Galaxy. Unfortunately, both clear nights were full moons nights, so tough to get details. There will be a dark clear night soon, she says. It will be for sure. But nice shots, Kathy. Thank you.
Absolutely.
Yeah.
I'm going to go from there to Matthew Dupre's capture here. Matthew has 2 hours on M101.
Yes, sir.
I captured this with a Celestron 9 1/4 and a 0.7 reducer, and then an ASI 2600 MC Pro. The focal length of the scope was with the reducer was around 1600 millimeters, and I found guiding very tricky. I ended up capturing enough data to stack a little over 2 hours worth of exposure. So
Nice job.
nicely
Yeah.
done. Great stuff. Jennifer DLG.
Wow.
Jennifer's getting into this now too. I've been busy with my C-Star S50 this past week. Well, we had miracle of miracles, she says, a few clear nights. I'm attaching some recent photos of M1.
Ooh.
So that one there, and NGC 7635.
Oh, yeah.
Nice.
Sure.
And M101.
There you go.
Yes, sir.
Still lots to learn, but I'm having fun. You bet.
That's what counts.
Yeah.
Exactly.
Awesome, Jennifer. Thank you.
That's great.
I'm going to move over to the sun here for a minute because these are a few captures from Robert Cadet.
Always nice. He's doing some nice work.
He does, yeah. Solar captures from April 27th, 2024 at 12 noon, acquired by Lunt 40 Scope, a Sharp Cap Pro 4, ZWO ASI 174 planetary camera, and stacked at 6% of 2000 frames using a Celestron Nexstar Alt-Az mount, processed in the IMPPG and Photoshop. But he's getting some pretty cool processing.
Oh, yeah. Nice details in there.
There's another nice shot.
And she's active.
Yeah, she is. This one is from David Hoskins. No, I don't know if that's still. I think that's still Roberts. Yeah, I got it in full screen right now. Yeah, that's still Roberts. Yeah, she's active, and it's 16 sunspots this week. I think it was.
Yeah, something like that.
One day.
Crazy.
Not as much aurora as what I was expecting, but sure, there's more coming.
It's coming. It's got to come.
Yeah. Now this one I think is from David Hoskins. Yeah. David says there are 6 sunspot groups left to right. AR 3656, 3655, 54, 53, 57, 52 in this filtered image I captured earlier today in hydrogen alpha. As I was setting up for an image session last night, I noticed Leo passing behind the trees. I had time for a few. Oh, this is the other picture here. Hang on. Oh, this is that one there. Sorry, I think that last one was, let me get back here. That's David's picture there. And that one was still Robert's. Sorry. All right, with that Robert. On a full screen, I can't see the names. There. So that's David's group of sunspots. That is a lot of sunspots together.
Yeah.
Unusual. I'm going to go from there to David's shot here. So he said, as I was setting up for an imaging session last night, I noticed Leo passing behind the trees. I had time for a few unguided 1-minute exposures of Regulus, blue-white star that is the brightest star in the constellation.
There you go.
Yeah, so that's really nice. Awesome. Well, if you guys have any photos that you'd like to share, we like getting them here, and we love sharing them as well. So you can send them into astronomybythebay@gmail.com. And Brad says, I got mild aurora up here in the past 2 nights. Oh, awesome, Brad.
Where's that?
In Fredericton, just outside of Fredericton.
Oh, really? Oh, wow.
Yeah. We'll go back to sharing here. Yeah, I mean, I know there was some M1. There was a lot of M1 solar flares, and there were so many of them that they said, expect some aurora because there's just so many. And most of them are going to miss the planet, but because there were so many, they were expecting some. And apparently that crack opened up that allows the particles in.
I noticed a few photos on Facebook of some people that picked up some aurora.
Yeah.
David Simard up there in Shippigan, he got a couple of shots on the low on the horizon.
Did you see a lot of it, Mike?
Well, it was low on the horizon. It's probably less than what we saw, definitely at the Florida beach, but
yeah,
you can make it out.
On there. Hey.
Hey, what happened?
Okay, well, I guess that's our show for this evening, then. We hope you enjoyed the program tonight. Special thanks, of course, goes out again to Rosanna for her fabulous fun fact segment. Thank you, Rosanna.
Yeah.
I don't think I'm going to climb that mountain, but I could never make it that far. Yeah, anyway. And thanks to all of you who share the program for us out there. Too, we do love sharing your photos, so send them in to astronomybythebay@gmail.com, and we'll be happy to share them on our next broadcast. Special thanks again to our friends for Rogers for joining us this evening. So until next week, everybody, wishing you all clear skies. Open your eyes to view the skies and keep your scopes. What do we say, guys? Keep your scopes.
Point it up.
Point it up. Is that what it is?
Hey.
Okay, let me see if I can share our outgoing screen here.
I know there is a planet you can see if you point your scope down.
That's true too. Here we go. Oh, that's the wrong one. Let's go back. That says we're live in the moment. Let's get to the closing screen. Oh, goodness gracious.